So polymer matrix used in the composites. Polymers are materials, which are the class of materials with flexible form and widely varied compositions. And the properties are changed as the polymer interact with environment over time. So structurally, polymers are large molecules built from many small molecules and can consist of many thousands of atoms in chain or network of repeating units. So as we know, this in chemistry, these repeating units are called monomers. So when monomers are connected to each other, then it produces a giant structure called polymer. And the process of doing this is called polymerization. So in chemistry, you have different types of polymerizations. So it is there in chemistry. So composites are hierarchical design of matrices and fibers and also other components. Okay, matrix and fibers are the basic component of composite. And there are also some other ingredients which should be added to form a composite. So polymer matrix composites are an important class of composites, which are used in aerospace industries, which are used in sport areas, which are used in space shuttles, uh, in lightweight cars. Okay, even in the biomedical applications for preparing or for different uh, due to its good strength and durability, and also so this is a very important class of material, and this is a challenge to develop history-based durability models that will enable composite developers and component designers to tailor the property of the matrix, that is resin, and the interstitial phase between matrix and fiber to the intended use. Just as I tailor the direction of fibers to principal direction of the loading. Principal direction of loading means the direction of along the direction of loading. So as we know, in composite, fibers are the load-bearing structural members, and the matrices are the one which transfer load from one part to another, and at the same time which enclose the fiber or it holds the fiber inside of it. So as use in environment go to extreme of stress, temperature, and chemical compositions and other factors, this challenge becomes both more important and more difficult. So actually, this such kind of composites are used in the area of high extreme temperature conditions. So polymer matrix composites are materials made up of more than one component. As I said, that components are mainly the fiber and the matrix. In this case, polymer is the thermoset polymers are considered as the matrix or the resin, and the carbon fiber is considered as the fiber. So this combination will yield us a high performance material. Okay, so the primary property of polymer matrix composite is generally that it is structural, but a number of other functional properties may also be built into it. So a multitude of layers, which are in a stack of lamina, what you can get, we call it as multitude of layers, and continuous fiber reinforced. Some of them are particulate reinforced and monoparticle field materials can be called as polymer matrix composites. Sometimes we can add some choked fiber to increase the strength and the functionality of the material, and the number of additives also counts. Okay, composites material consisting of micron diameter. Actually, the fibers are very micron in size. Most considerable size of fibers are about 6 micrometer or 8 micrometer or 10 micrometer maximum, as stated by many researchers, which are very good for the high performance material application. We cannot need that bigger size of wire. It has disadvantage. When the size of wire increase, uh, it is not like as that micro fibers. So such fibers are bound in a polymer matrix, which thermoset polymer matrix is particularly. Okay, not the thermoplastic polymer, but thermoset polymers, which are resins are used here, which are combined together to get high performance structural material or application. So polymer matrix composites, in many cases, these are a continuous carbon fiber. The two constituents mainly is continuous carbon fiber in a high temperature thermoset resin material. That is a suitable material for high performance material. But they can also be other fibers may used or other resin type we can use. There are PEG type resin. We have different specification of resins are there. As the size of dispersed phase become much smaller than micron, the distinction between the composite and the blend are blessed. And so does the boundary between continuum and the molecular mechanics will become. So staying in the area of nanoscale fillers. We are currently using a nanoscale materials also. So actually the problem of the use of this nanoscale is it needs high computational cost and it needs high performance computers. So they stayed in the area of nano fillers and the molecular dispersions in both fibers and resin is just an emerging technology that is known as nanotechnology. And the modeling of this material is inconsistent. That is the only problem. So nano size inclusion fundamentally affect polymer mobility, allowing the mechanical and thermal properties of composite to be dramatically altered even with very small volume fraction. Okay. So this table shows the characteristic and application of high performance fiber reinforced polymer matrix composite. So the characteristics are listed here and applications are given here. So the basic characteristics include specific strength and toughness. Then means these high performance composites that the composite made from carbon fiber and the polymer matrix are having a good specific strengths and the toughness. The specific stiffness, the stiffness of material is high, strength is also higher, and it is also lightweight. So such materials are applicable in the area of aerospace, construction, sport goods, and lightweight automobile industries. Why we are using this lightweight structure for aerospace application? This is basically due to the relation between the weight of material and the fuel consumption, the relation between the weight of the material and the environmental effect. Okay, whenever the structure of an aircraft is higher, obviously it needs higher fuel. It consumes higher fuel. And these fuels are fossil fuels, which are the output of those fuels are like carbon dioxide, okay, and other environmentally incompatible materials. This the combustion product of fuel can affect the environment, so that it directly relates to the weight of the aircraft, so that we use this lightweight structure for the construction of aerospace structures. Like about 50% of the aircraft structure is made from composite currently. That means directly from carbon composite, especially the Dreamliner 787 is made from this. Another characteristic is high dimensional stability, low coefficient of thermal expansion, and low aberration. So the printed circuit boards, missile structures, aircraft brakes, aerospace antennas, and support structures, large telescopic optical bench, waveguides for the stable high frequency precision measurement frames. These all are made from such material. So this is due to the high dimensional stability and low coefficient of thermal expansion, as well as low abrasive behavior. So it is not um, um, give wear and tear immediately like as other structures. So another application, another characteristics, vibrational damping characteristics. Okay, it has a good damping characteristic. It does not give the vibrational structure to the hair oscillation. Another is strength and toughness. So it is having high specific strength and toughness. So due to that, it is used for audio equipment, including microphones and speakers. Robotic arms are made from this material. The fourth characteristics is electrical conductivity. So this material are used in the airframe and the aircraft skin material, novel tooling, casings and bases for electronic equipment, electromagnetic interference, EMI, and radio frequency shielding and brush. So this is due to the electrical conductivity behavior. Another characteristics is low biological reactivity and permeability. So medical processes, again, surgery and X-ray equipments, implants, uh, tendon and ligament repairs are made from this material. Especially currently, the most engineers or designers of this material trying to cover many medical related equipments for the implementation of human teeth, for example. Human teeth, actually, naturally, the human teeth by itself is a composite, but still, if this human is damaged, then people try to replace it with the composite materials. Okay. Another, not only that, but some of the surgery equipments, okay, which are very, actually that is related with that nano material, the surgery